G'day everybody, where's Wally here? Well, today I'm going to do something a little different. You know, we've all got a pet Flattie somewhere along the way. You know, one of those people who they come to your channel and tell you you're wrong. You go to their channel and laugh and tell them they're wrong. Well, today I thought I'd just show you some of the things that my Flattie puts on the channel. And to be honest, it's all very old stuff. And I know they think they're being very innovative, but it's stuff we've all seen before. So I thought I'd just do a quick rip through them all and point out exactly where they're wrong. Oh boy, I laughed so hard when I read this one. Yeah, no one says that. No one says that gravity gives density or that gravity is responsible for magnetism. Come on, learn science, guys. Well, gravity from a single atom is going to be very, 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 very small. Luckily, physics is still okay. And when it comes to a planet, all of the atoms in the planet contribute to the gravitational attraction, and we use the center of the planet as a convenient place to measure it from. And of course, if you want to look at the phases, here's a nice little experiment where you can actually compare a ball right in front of your eyes to the phase of the moon, and it will always be exactly the same when both of them in the same sunlight. And even if you look at the ISS, there's that little ball-shaped thing on the right, little part of the Soyuz capsule, pretty much exactly the same angle as the moon in the distance. I would call that a win, wouldn't you? In fact, the Earth also reflects sunlight just like the moon does, straight back into space. And we can see on this photo here, there's a thing called Earthshinne, and it's on the unlit side of the moon. And you can see it when the moon is in a very small crescent. So what's happening is the light is coming from the sun, hitting the Earth, reflecting back into space, hitting the moon, and reflecting back to the Earth to be seen by us. Too easy. Well, the moon is totally reflecting sunlight, guys. You can even see the shadow in the craters. As the sun angle changes, you can see the shadows change. I even photographed it myself. Now, these two photographs were taken about 22 hours apart, and you can see the difference the changing of the sun angle makes. Yeah, impact craters and shadows and all that, they change by the hour. It's solid. Earth Zero, is that a new Coke variety, is it? And by the way, speed is never felt, it's only acceleration. And the water in the ocean, well, guess what? The water is held by the water beside it, and the water beside that. Right the way around the planet. Too easy. Oh boy, this one gets me every time, because this is the one time you should be using perspective and you just forgot to. And of course, we all know we're not China, so it gets launched over water in case there's a failure, and then it just goes splash. Too easy. Yeah, look, if you're too lazy to make this readable, there's no way I'm going to bother. Anyway, pretty moonrise. Looks good. Probably just crossed the horizon in one disc at a time, didn't it? Yes. Well, this is a good one, but of course it's based on a fake premise. The shuttle, when it's coming back in, or any spaceship, is, well, as you can see here, it's doing a lot more speed on the way back than on the way out. Thus, that's why it's heating on the way in. But look, better still, I'll let Reds explain it. Enjoy this next 1 minute while Red's Rhetoric explains exactly how this works.
So, back to the shuttle. Here is a diagram that shows the difference in speed compared to launch and re-entry. At 60 kilometers in altitude on launch, the orbiter is traveling at roughly 1400 meters per second. During re-entry, it's traveling at roughly 4400 meters per second at the same altitude, which is 3.14 or pi times faster. At 80 kilometers in altitude, the discrepancy is even worse. On launch, the orbiter is traveling at roughly 1700 meters per second. During re-entry, it's traveling at roughly 7400 meters per second at the same altitude, which is 4.35 times faster. So no shit, it's going to need more thermal protection on re-entry than it will need during the launch. So your apparent claim that the launch phase of the mission has the same stresses as re-entry is 100% incorrect.
Well, I can't believe anyone would put this one up as a meme. You mean you don't understand how rockets work, where the various components are stored in the nose of the rocket? Did you even Google it? I mean, how many tabs have you got open? Like 3. Oh, this is the funniest one. Wolfie loves this one. Of course, when you go to Perth and you look at where the sun is actually rising, it's quite a few degrees different to where it would rise if it was on the flat Earth. It just kills this whole gum clock idea every single time. Doesn't match reality at all. Who's looking at this? Who's checking it? Well, of course, no one's ever flown a plane over a CGI Antarctic because it's a real Antarctica, and of course they fly real planes over it all the time. Look, just go and ask Greater Sapien and Critical Think. They went there. Well, nice try, but you're rounding off to get the answer you want. It's actually 66,627 miles now, so that sort of ruins it for you. And the number of degrees is 23.5, not 66.6. Sorry, that's ruined it again. And of course, the curvature squared is nothing like what you came up with. It's sort of like 8 inches squared, 64 inches. That's nothing like 666 feet, so that's a big fail. So, if the stars have changed their relative positions in the sky, that would prove the heliocentric model, yes? Well, a faint star called the Bernard star is the fastest moving star in the skies, and still, for it to move and change its position by amount equal to the width of the moon takes about 180 years. So surely the constellations have changed shape, but it just takes a very, very long time to do so. Oh, goodness me, not the chroma key claim again. Now, if anyone knows how chroma key works, white is not the colour that you can use because it doesn't get subtracted properly. And of course, someone actually went and found that graph kit thing that's available in eBay somewhere. You can buy it. It's a 4 foot by 5 foot, made by a company called Nomex, and the size and scale matches exactly. So it's just a chart for educational purposes. It's even got axes on it. Goodness me, guys, you're really, really, really stretching here. Okay, I can sort of see where you're going here. Those couple of boats and cars and things all push against something. But, you know, a rocket works by tossing stuff out the back really fast, very fast. So what you might even be able to say is that a rocket works by pushing off of the exhaust gases. How's that? Okay, solved? Don't want to see this one again. To get up in space, you go up. To stay in space, you have to go around really fast. And here's another frequent Flattie strategy that we see. It's called avoidance. So they address the easy point and then run away from all of those tough points. And here is another strategy we often see by Flatties. You can see that they're informed by Hollywood, not science. Come on, guys, movies are fake. Science is real. Hollywood makes things look good to appeal to people so they come and watch the movie. It's as simple as it gets. So there we have it, folks. All of those debunked and made fun of at the same time. It's very, very easy to do when you've seen all these for years and years. Anyway, it hardly rates as what you'd call proof. What do you think, guys? Anyway, enjoy my final destruction of the flat Earth. Here we go. Okay, so if you like that, how about you click and share and subscribe and be the first to get in on the next fun little adventure into destroying the flat Earth. Now, while you're doing that, I'm going to literally destroy this little thing here.